All right, welcome to lesson 3.1.3, day 1. Let's start off with our vocabulary words. So our first vocabulary word is the argument of a function. I know that sounds really weird, but the argument of a function is just another word for the input of the function. So for example, if you have the function f of x, and remember, f of x is the most standard way we can write a function. You could use g of x, f of x, whatever letter you want, but in our case, the most standard one is f of x. In f of x, the argument is x, because it's literally the thing that the function takes in. It's the input, it's the x value, it's the thing that you plug in to your function. So arguments of a function is simply just the input of a function. All right, let's go on to the next vocabulary word, which is reflection. I think you guys kind of already know what a reflection is, but let's just kind of define it more in terms of math. A reflection is pretty much just flipping your graph around. Across something called the line of reflection. Which is obviously the next vocabulary word. So the line of reflection is the line that the graph gets reflected across. Okay, so let me just draw a couple of pictures so that you know what's happening for a reflection and the line of reflection. So let's say here is my x and y axis, and I have a picture of a happy face. Okay, so this is my graph. I know it doesn't look like a graph, but it is. So this is my graph, and I'm going to draw a blue line of reflection this way. So I'm making the x-axis my line of reflection. So this line of reflection is the blue line, okay, that I just dropped, the dotted blue line. So once I reflect this picture, it will look something like this. Obviously, I'm not drawing it that well, but that is my reflected happy face. So this is a picture of a reflection, and the line of reflection is that blue line. So it's essentially the mirror. The line of reflection is the mirror in this situation. Okay, and so let me just draw you one more example. So let's say I have a heart like that, and I want to reflect it over this line. Okay, so if I want to reflect this heart over that blue line, this blue line of reflection, it will end up looking something like, I'm not drawing this very well, something like that. Okay, so the heart is the original image, and then it gets reflected across the line of reflection, and then it turns into the sideways heart. Okay, so this is essentially the reflection, line of reflection, stuff like that. Okay, so now that we got the vocabulary out of the way, let's get on with the first part, which is vertical translations. So for vertical translations, we're going to graph each transformation and write the equation for the transformed function. So our most basic original function is f of x is equal to 2 to the power of x. Okay, and then here are some points that are just given to us. They are part of 2 to the power of x. So on 2 to the power of x, there's 0, 1, 1, 2, and 2, 4. And then we are going to perform this translation. So what is a translation? It's literally moving the graph left, right, up, down. But if it's vertical, it's just moving it up, down. So literally just taking your graph and moving it up or down. So over here, it says g of x is equal to f of x minus 4. So notice that the minus 4 happens outside of the parentheses. Anything that happens outside the parentheses is a vertical something. In this case, since we are subtracting 4, this is a vertical translation. And so take a look at what happens over here. This minus 4 ends up being y minus 4. So we place it right over here. When you have an original point, xy, it becomes x comma y minus 4. And that minus 4 comes from that minus 4, okay? So let's get on with actually writing out the next few points. So on f of x, there's the point 0, comma 1. Now on g of x, our new transformed equation, we're going to have the x stays the same, so it's 0. And then 1 is our original y value, but we're going to go minus 4. So let's simplify this again. I guess I'll just write it out here. 0, comma, what is 1 minus 4? 1 minus 4 is negative 3. So originally the point on f of x was 0, 1. On g of x, the new equation, our point will be 0, negative 3. Let's do it again for the next point on f of x, which is 1, comma 2. So remember your x value stays the same because this is a vertical translation. Vertical translations go up and down. If you're just going up and down, you don't want to change that x value. So the x value stays the same. Now for the y value, that's what we want to change. So we want 2 minus 4. And so we're going to simplify this. The 1 stays as 1. 2 minus 4 is negative 2. So our new point on g of x is 1, comma, negative 2. Let's do the same process again for the third and final point on f of x. So that point is 2, 4. Remember, the 2 stays the same. That is your x value. If we are just moving our graph up and down for a vertical translation, then you don't want to change your x value. Our x value stays the same. So 2 stays as 2. The y value is the one that's going to change. So we have a 4 originally, but remember we are subtracting 4 from that. So 4 minus 4. And that becomes 2, comma, 0. And so finally, let's graph this g of x. Sorry, I just don't know why I couldn't talk. So we're going to graph g of x. So we're going to graph these 3 points. So 0, comma, negative 3. That's right here. 1, comma, negative 2, 2, comma, 0. So I know it's a little bit hard to see, but let me first draw you our original function f of x. Our original function f of x would have looked like that. So remember, exponential functions look like that, right? We just kind of did a lot of lessons on what exponential functions look like. So hopefully you remember that that's what they look like. Now for g of x, it's going to look like that, okay? So this is our g of x graph. And so I can label it g of x. And then we also need to write the equation for the transformed function. So originally f of x is equal to 2 to the power of x. G of x is equal to f of x minus 4. So g of x is equal to f of x. Remember, f of x is 2 to the power of x. And then we have minus 4 at the very end. So I wrote that right there. So it's 2 to the power of x minus 4. And now what will be our horizontal asymptote? Well, our horizontal asymptote is simply this number. So y is equal to negative 4. And you can see that right over here. I'll draw it in yellow, a dotted line across at the negative 4. So that is the line that your equation or your graph will never cross, but it will get closer and closer to. Notice the black line gets closer and closer to the yellow dotted line, but I'm not going to cross it, okay? So that is where your horizontal asymptote is. It's the number that's added or subtracted at the end of your exponential. All right, let's try number 2 together as well. So let's take a look at our equation. we have f of x is equal to 3 to the power of x. Remember, originally that graph's going to look something like that, okay? Now we're going to vertically translate this graph. And remember, vertical translations means up and down. In this case, we are adding 1 to the equation. So g of x is equal to f of x plus 1. So our corresponding points on g of x, if we're moving it up and down, we're not going to change our x value. So x stays the same, but we are going to change the y value. And so notice what happened over here. When it says minus 4 on the outside, that's y minus 4 over here. And so since this one says plus 1 on the outside, we're going to say y plus 1 over here. And I think some of you can already guess, do you think it's going to go up or do you think it's going to go down? Because on number 1, we subtracted 4, it went down. Number 2, we're adding 1, so it's going to go up. All right, let's take a look at how each point changes. Remember, these are vertical translations, which means your x value stays the same. So 0 stays as 0. However, the y value, you're going to add 1 to it. So 0, comma, 2. Once again, x value stays the same. So 1 stays as 1. Y value, add 1 to it. Why am I adding 1? Because that's what it says to do in our equation. It says add 1 to the y value. So this is 1, comma 4. And then last but not least, we have 2, comma 9 plus 1. Remember, the x value stays the same. The y value changes because this is a vertical translation, which means we are moving up or down. And so only the y value can change if we're doing something vertically. Remember, the vertical, is the y value. So that's the one that's going to change. It's the up-down direction. All right, so now we got our points. Let me plot them. So 0, comma 2, 1, comma 4, 2, comma 10. Okay, so maybe it's a little bit harder for you guys to graph it without first seeing the equation and knowing where your asymptote is. So let me write out the equation. So f of x is 3 to the power of x. G of x is f of x plus 1. So g of x is equal to f of x plus 1. And so what do you think our asymptote is going to be? It's the number added or subtracted in the end. So it's going to be positive 1. So actually, let me draw that asymptote in first. So here's positive 1. Drawing the horizontal asymptote. So your graph needs to stay above this yellow line, okay? You cannot go below that yellow line. Okay, you can get really close to that yellow line, but you cannot touch it. You will not cross it, you cannot touch it, you must stay above. So this is what your graph for number 2 looks like. So I actually recommend you plot your points and then find your asymptote and then graph it. So you know exactly where your graph is supposed to look flat at, okay? All right, so that's numbers 1 and 2, and I believe that is it for the vertical translations. Remember, vertical translations is where we move the graph up and down. Let's take a look at what's going to happen in the next video when we do horizontal translations. So I'll see you in the next video.